exponential functions. I'm not going to spend much time on graphing, but I will show you on the homework how to graph them. We're not going to go through all putting in x and y points and doing all of that. We're going to use our calculators to do the graphing. So if you look over at the homework, and I will be flipping back and forth to the homework a lot today, there's several different types of problems. So I'll try to show you an exact example and then show you in the homework which problems match up to those. So we will do problems 1 through 3 there, which they give you a graph and you're supposed to match up the equation with them. So if you look at number 1, you have y equals 5 to the x. So I would go to y equals 5 to the x and hit graph. You might have to graph them all 3 before you can pick. A couple of those graphs, if you look at them, are very similar. So you might have to graph all 3 to see which one matches up exactly. I will say, looking at those two, A and C graphs, that's exponential growth. As you move to the right, the blue line is pointing up, the graph is pointing up, it is growing. The one in the middle, as you move to the right side, it started up high, and it's decreasing exponentially. So that is exponential decay. That's what those two graphs look like for growth and decay. And then 4 and 5, they say to sketch the graph. Those we're not going to do, at least right now. We will, since it is the end of the year, there will be some things we won't go as far in depth as others. So we're trying to hit the last things that will be on your final. So that's pretty much it for graphing. So if you look over at page 500, we'll get into actually what these equations look like. So that's an exponential growth or decay equation. They both look the same, but there is one distinct difference as far as when you put numbers in that will tell you whether it is growth or decay. B is the key. B will tell you whatever number is in the place of B, that's the base of that exponent. That tells you whether it's growth or decay. If B is greater than, not 1, B is greater than 1, it is exponential growth. And you literally have homework problems that will give you an equation and say, which is it, growth or decay. If B is between 0 and 1, so it can't be negative. But if it's between 0 and 1, that is exponential decay. So y equals AB to dx. That's the equation you're going to be using all day. You'll be writing some of your own equations. But starting off, we're just going to be looking at that and telling whether it is growth or decay. There's a couple of examples on page 500. Y equals 1/5 to the x. So looking at that equation, what is A? One, not 0. If it was 0, the whole thing would be 0. There is no A right here, so you assume A is 1. What's B then? 1/5, so would this be exponential growth or decay? Decay, it's obviously between 0 and 1, and that's all you have to write on that one. And the next example there is y equals 7 times 1.2 to the x. So what's B in that problem? 1.2. Again, that A, the 7, whatever that is out front really has nothing to do with this type of problem. You're just looking at the B, and in this case it would tell you it's what? Growth. Pretty simple. And there will be a few of those in the homework. If you look at 6 and 7 over on the same page, and then 22 through 27 on the next page, those are all problems like that. Pretty simple. Just look at B, tell me what it is. The next thing we will do is write an exponential growth or decay equation. Just like you wrote a linear equation. They give you 2 points. you can write an exponential equation. Such as 0, 3 is 1 point, and 312 is another point. So they're giving us these 2 points, and they're telling us to write an equation for this exponential growth or decay equation. So you're always going to start off with y equals ab to the x. Just like with linears, you started off with y equals mx plus b. And problems pretty much work the same way. They're always going to give you this point, 0 something. Does anybody know what that point is called? Y-intercept. They're always going to give you the y-intercept. Whatever that y-intercept is, in this case is 3, that is always a. And they will give you that on every single problem. Every one that asks you to write the equation, they will give you 0 something, and that is always a. The only other thing you have to do is plug in this x and y for the x and y. So we'll put 3 in there, and we'll put 12 in there. So what don't we know? The b, and that's what we have to solve for. Just like with linears, you didn't know slope, you had to solve for m. Now you're solving for b. So if we do that, 12 in for the y, 3 in for the a, we don't know b, and should have put another number in there, but the other 3 goes in for that a. So if we're solving for b, what do we have to do first? Divide by 3. So we get 4 equals b cubed, and we still have to get b by itself. Not cube it, cube root it. So that cancels. Now we have b, and we need the decimal for the cube root of 4. So remember on your calculators, there's two ways to do these. If you gotta hit the 3 first, since it's cube root, so you push a 3, hit your match key up here under alpha, and then hit 5, and it will bring the cube root in there for you. And you hit 4, enter, and what do we get? 1.5874, yada yada, so 1.59 would work. The other way to do all of these problems, instead of going through and doing the root, is you could have done 4 to the 1/3 power. Either way will work. So if it's easier to type 4 to the 1/3, some people think it is, that's totally fine to do as well. Whichever way works better for you. So continuing with our equation, now we know what b is. We finish up by just plugging that in. So now we change it back to y. 3, a is still 3, 1.59 to the x, and that finishes up the problem. So that's how you do it when it says write an exponential equation. We'll do one more. Are there questions before we do?
Do you ever use this in fraction or always use this in fraction?
Most of these they wouldn't go into a fraction because they're irrational, so decimals are fine. So we'll try 0, 6, and 6, 4, not 6. We'll do 7. So what's A? 6. So again, pretty simple once you know how to do it. And what are we going to put in for the Y? We're going to put what? 4. So 4 equals 6. What's b? B is b, and our exponent is 7. That's what we do to solve for b. Divide by 6. And I would leave that as a fraction. So 2/3 equals b to the 7th. So then we take the 7th root. And what do we get? 0.9 what? 0.94. Everybody else get that? Okay. So then your growth or decay, this one would be decay, equals 6 times 0.94 to the x power, and that would be your final answer. So this was kind of introducing how to write the equation. The other problems will be application problems. So you're going to be given actual real world stuff and you have to write the equation. They're going to give you the same information. They're going to give you basically 2 ordered pairs. It's just not going to be written out like that. So you're going to have to get that information out of paragraph. But you do the problem the same way. At the bottom of page 500, we'll do example 3, population example, which exponential growth and decay are often used for populations to calculate what a population might be on down the road. So it says in 2000, the population of Phoenix was 1,321,045. So in the year 2000, that was our population. And then they're going to give you the exact same information about a later time. In 2004, the population was 1,331,000. I didn't write this one down. So obviously you can see there that there was some growth between those 4 years. It didn't grow a ton, but it did grow some, and it's normally going to grow exponentially. So you've got to write an equation based on this, and then we'll use that equation to figure out a later date. Which is what it says next for A. Write an exponential function of the form y equals ab to the x. It could be used to model the population y of Phoenix. And this next part is very important. Write the function in terms of x, and x represents the number of years since 2000. So basically, these numbers right here become your ordered pairs. But what does x represent? The number of years since 2000. So what would we put this to be, the number of years since 2000? That would become 0. If you want to rewrite the ordered pair, that's fine. So you can see that it was 2000. We changed it to 0. Either way, but since x represents the number of years since 2000, you don't actually put the year in. You put the number of years since 2000. So this one would be 4, and you've got your 2 ordered pairs, and you do the problem the same. Y equals AB to the X. So what is Y? First one? The second. So Y is 1,331,391. A is the other population. And what's B? And 4 becomes our exponent. That's the number of years. If you solve the same way, so we got to divide what does that become? 1 point. I thought it was 1.008. Is that what anybody got? Okay. And then take the fourth root, or take it to the 1/4 power. Either way. So what is B? Still 1.002. And since you have B, you can now write your equation. Remember, A stays the same as it was. It's still the first population. And we put 1.002 in for B, and the exponent stays X. Question? No, you'll still end up close. You should be very close, though. So. I wouldn't advise talking anymore today. You're going to find yourselves in quite a bit of trouble pretty quick. So A or B on the next page says, suppose the population continues to increase at the same rate. What would be the population in 2015? So now that we've written an equation, we can use that to find any year. So what would X be for 2015? 15, very good. I would do the exponent first. Remember, you cannot multiply these two numbers together until you do the exponent first. You can type that whole thing in like that. Should work. Your calculator will know to take it to the 15th first, but just don't try to multiply these first and then take it to the 15th. And you should get something close to 1,360,262. So if you round it differently, your answer should still be very close to that. And again, if you want to look at your homework, over on 503, numbers 10 and 11, actually 6 and 7, or 8 and 9 are the first ordered pair problems we did. 8 and 9 look just like this one, so use that as an example. And then 10 and 11 look just like this one does. So follow that example. What's your first year on number 10 and 11? 1993, so you're going to make that be 0. And what's the second year given? So that would be 12. So that would be your second X value, would be 12 for that problem. Last thing is bottom of page 501. We'll continue on over to the end, but it is solving exponential equations. Sounds crazy, but there were several kids that actually said this was semi-fun. Probably not many of you will think that, but hopefully a few. So we look at that first one on 501. We have 3 to the 2x plus 1 equals 81. And what do we do when we solve an equation? Right, so we've got to get that variable that's right now in an exponent. We've got to end up down here with x equals a number. So we've got to get that x by itself. So what you have to do is get these two base numbers. In this problem, we have a 3 and an 81 to be the same base. So we have to rewrite 81 as a base 3 number. And you couldn't write 3 as any other base. Nothing to any power is going to give you 3. So that's got to be your base. You got to get the other one to be 3 in this case. So you just say 3 to the what power would give you 81. What? 4 to the 4th. So what we change that to is 3 to the 2x plus 1 equals 3 to the 4th power. So now you have the same base, so those 3's, and as long as that's the case, you can set those two exponents equal to each other. Two x plus 1 equals 4, and then it's obviously a very simple equation to solve from there. So we should get x equals 3/2. On the next page, we have 4 to the 2x power equals 8 to the x minus 1. So are they the same base? Now in this case, you could change the 4 and the 8. So you got to figure out what your base is supposed to be. It might take you some trial and error to figure that out. 4, is there anything you can take 4 to that will give you 8? Or anything? No. So you know 4 is not your base, which means both of these numbers have to change, and really 4, there's only one other way you could write that. As a base 2 would be 2 to the what? So you need to put that part in parentheses. You're changing the 4 to 2 squared. And you still have the other exponent out there of 2x. So what's 8 as a base 2? 2 to the what? 3rd power, so you change that. And you still have the x minus 1 for that exponent. So our bases are almost the same, but you need to combine these exponents. So this is power to a power. What do you do with the exponents? What? Multiply. So 2 times 2x. So you now have 2 to the 4x power. And you got to do the same thing on the other side. Be careful because you have to distribute when you multiply these two together. So we have 2 to the 3x minus 3. Now your bases are the same, set them equal. Another easy equation. We have x equals -3 for that. If you look over at your homework again on page 504, where we have problems just like this, we're going to do a couple of those. You look at number 12, for instance. What's the problem with 12 that's different? What? It's equal to a fraction. So we know, some of us may remember how to solve that. We have 2 to the x plus 4 equals 1 over 32. So what's the exponent with the 32 down there? Right here. Of 1. So we need to get that to the top. What would that exponent become? -1. Very good. And that's all that you have to do on that problem. If you have a fraction, move it up to the top. So that stays 2 to the x plus 4. We now have the 32 on top to the -1 power. Then you do the problem the same. You got to get the same base, which, since you've already got a 2 for the first base, that's what your second one's got to be as well. So 2 to the what gives you 32. Good. And don't forget that you gotta raise that to the -1 power. So we'd have 2 to the what? -5th, and set them equal. So x is what? -9. So one more type of problem, number 15 there. What's different? It's an inequality instead of an equation, and if you remember back to linears, you solve them the same way. You do here as well. What's the only difference between equations and inequalities when you solve? Multiply or divide by a negative, you have to flip the sign. I did look through all the homework, and I don't see any that have a flipped sign, so I don't think that's going to come into play. But it's good to review the rule, and it's good to keep that in mind anyway. So we have 5 and 2x plus 3. Is less than or equal to 125. Can you change 5 to anything with a smaller with an exponent? No. So you know that's your base. So 5 to the what's 125? And you set them not equal because they're inequalities, but you do the same thing. 2x plus 3 is less than or equal to 3. So what do we get? X is less than or equal to 0. Homework starts on 503 and 504. One through 3. 6 through 17. 22 through 32. 40 through 48. And 53 and 54.